Let's put the previous result into some use. Yes, I'm not writing in terms of reduced homology groups, but that is understandable. You can put reduced sign on top of it. So first note the following. Yeah, so this result we are going to use. So x comma I. So if you're given something like this, you have to compute this. Now either you can write a long exact sequence of groups and then start cancelling them out, or if you know the result on the left, you simply write this, put the reduced sign, and now you know the homology of sphere is really easy. You know, it is non-zero only in dimension p plus q. So without writing the long exact sequence, you are able to calculate the homology. So this result is powerful for computations. Yeah, second is consider the space X. This is a two-hole torus, and consider this small set A. Yeah, so this is X and this is A. So let us put A in a different color, say blue, so that it makes our life easy to identify. So now again we want to compute the homology group of X comma A. So what is it? So what is X by A? So you collapse the circle A to a point. Yeah, so now let us write the corresponding chain complex. So in C2 there is only one cell, 2 cell, which is attached both places. In C1 there are 4 cycles which still exist, and in C0 there is just one vertex V. So multiplication is by 0 because all the cycles have the same vertex for dimension. So I'm not writing the reduced homology groups, but for reduced homology groups you have to do nothing much except check for dimension 0, and since there is a single vertex, it will be 0 there. So since it's a multiplication by 0, the entire chain complex Ci, that is C0 gets mapped to 0, C1 gets mapped to 0, and C2 gets mapped to 0. So H0 is Z, H1 is Z4, and H2 is Z. And when reduced homology groups, doesn't matter for C1, C2, for 0 it will become 0. Now again consider a torus, and then I have drawn a cycle A there again. This is torus, this is this circle A. So I want to collapse the circle A to a point. Now both these problems are problems in Hatcher, so you must see those problems. So yeah, so we have collapsed A to a point. So we want to compute the homology of space T comma A or T by A. So what should we do? So first notice that you take a sphere, you take a point at the north pole and a point at the south pole, and you connect them via one cell A. So there are 2 0 cells, you have taken north pole and south pole, and then you also connect them through the surface of the sphere B. So B is one cell and A is one cell, but B lies on the surface of the sphere. So if you collapse A, what you get is same figure. But what if you collapse B? If you collapse B, this is what you get. You still get a sphere, this is the point. So we have seen that X by A is equivalent to X by B. So if you want to compute X by A, we have to write the homology group of S2 wedge with S1. So again there is a 1 0 cell which is a vertex P where both the products are wedged. one cell which is S1 and S2 is one cell corresponding to 2 cell is S2. Yeah. So again, reason as before, HI is equal to CI. So what is the homology group of T comma A? It is nothing but the homology group of S2 wedged with S1. And now you can compute reduced homology group. The only thing you have to do is H0 is Z, but reduced H0 will be 0. Everything else will remain the same.